Okay, here's the problem-solving video for problem 2.76, and we're going to use a problem-solving strategy on page 49 for analyzing circuits containing a single source and series parallel interconnection of resistors. Step 1 says systematically reduce the resistive network so that the resistance is seen by the source. The resistance seen by the source is represented by a single resistor. So there's our first step. We're going to start reducing the network down. Okay, and if we look, for instance, this little connection here might give us some concern, but really we could kind of take and squeeze these 2 points together, or if we look, these two resistors are in parallel, these two resistors are in parallel by the way they're connected. So you could think about taking these 2 points and just squeezing them into a single point. Another thing is, if we look over here, those two resistors in series, we're not going to worry about V2 yet. We're going to solve for it along with V0 and V1. So the first thing to do is let's start reducing that network down. And when we have a 10K and 20K in parallel, that's an equivalent resistance of 6.67 kiloohms. A 5K and a 10K in parallel, that gives us 3.3 kiloohms. These two in series gives me an equivalent of 12 kiloohms. So now let's redraw the circuit with those combinations. Okay, so here's our 16-volt source, 3 kiloohms. This is 3.33 kiloohms, 6.67 kiloohms. Here's 4 kiloohms. The voltage V1 is a voltage there. It's still in the circuit. However, the voltage V2 has disappeared. And that's because that was a voltage across the 8K, and that is now gone. The voltage V0 is across the parallel combination of the 5K and the 10K, so the voltage V0 still appears there in this circuit because those two elements were in parallel. Now, let's look at this circuit. These two are in parallel. These two are in series. Okay, so let's redraw the circuit again. So now, over on the left, we have 10 kiloohms. We have the 3 kiloohm and the 16-volt source. Now we've got the 4 kiloohm. This is still a voltage V1. This combination of the two 12s in parallel is a 6K. And we have that. So now, if we look at these two resistors, they're in series. We combine those. Let's redraw that circuit. That circuit becomes this one. Okay, this is a 3 kiloohm. Here's a 10 kiloohm. Now, V1 no longer appears in this circuit because that 4K resistor was combined in series with the 6K. Now, if we notice, these two are in parallel. Okay, so now our circuit can be reduced to the following. Two 10K resistors in parallel is a 6K, or excuse me, a 5K. So now we got two 10Ks in parallel as a 5K. There's our circuit now. We've really reduced our circuit down to a source, and really we say a single resistance. If we want to, we can take one more step and draw our circuit as this. So this takes it all the way down to a single resistor and a source. We put the 3K and the 5K in series. That satisfies step 1. Now step 2 says solve for that current. And from Ohm's law, then this current I1 is 16 volts divided by 8K to give 2 milliamps. Okay, so now we're going to backtrack through the circuits we've drawn to find those voltages. So here's 2 milliamps. Okay, here's 2 milliamps in this circuit. Now, we've got equal resistances in both of these paths by current division. This current splits equally. So there's 1 milliamp flowing in those two directions. So the 2 milliamp splits into the two 1 milliamp currents. Now let's back up a circuit. Let's go back to this circuit. So now we have 1 milliamp. We have 1 milliamp. Okay. So now if we notice from Ohm's law, the voltage across this resistor is going to be 4 volts. Okay, with that polarity. So that indicates, since V1 is the opposite polarity, V1 is minus 4 volts. Okay, so V1 is minus 4 volts. The voltage across the 6K resistor is going to be 6 volts. Okay, now if we back up to this circuit, there's 1 milliamp in that direction, 1 milliamp in that direction. Now we know that the voltage here is 6 volts. So now we know the current and voltage. So V0 is 3.33K times 1 milliamp, or V0 is 3.33 volts. So now we can calculate that from this circuit. And that also tells us that this is 0.5 milliamps in that direction. So now we need to back up one more circuit to be able to calculate V2, because we know that current is 0.5 milliamps. That's the same current that flows through that 8 kiloohm. So V2 is 8K times 0.5 milli, or V2 is 4 volts.